Okay, welcome to this video where we'll be having a look at the AS Pure Mathematics chapter on integration. Now, as you can see, we'll be looking at all of integration here. We're going to look at finding integrals, indefinite integrals, finding functions, definite integrals, areas under curves, areas under the x-axis, and areas between curves and lines. So, as with all of these videos, we will go through one part of each topic within the chapter, and before we do that, I'm just going to quickly show you how the video works and how to use it. So let's have a quick look at that now. So when you are on one of these videos, if you click into the description, you can see the video there where I cover all of the AS Pure curriculum, and if you scroll down, you can also see all of the chapters. Now, these will slowly be filling up until it is filled the entire AS Pure curriculum, so hopefully by the time that you are watching this video, all of them will be actually in the description and you can click and watch each chapter. If you click onto the video and click the link in the bottom left there, you can actually see all of the chapters that are within this video as well. So you can skip through and have a look at the pieces of that chapter that you are needing to have a look at for your revision. So that's how this video works. Hopefully that's useful and helpful. If you enjoy this video, please don't forget to like the video, don't forget to share it with some of your friends. But with that being said, let's get started. When we looked at differentiation, we looked at this particular graph, and this is the graph of y equals x squared. So we had a look at this and we had a look at how to differentiate that. And when we differentiate it, okay, we multiply the coefficient of x there by the power. Okay, so when we differentiate it, we wrote it like this, dy over dx. There we go, and we multiply the coefficient of x there, which is 1, so we multiply that by 2, so we've got 2x. And then we reduce the power by 1, so we reduce that power of 2 down to a power of 1. And we got this here, 2x. Now when we're looking at integrating, we're essentially looking at doing the complete opposite here. We're just going to reverse this process. So instead of multiplying the coefficient and reducing the power, we're essentially going to increase the power and divide the coefficient. And when we write this out, we write it out like this. Okay, and this little symbol here, which I'm going to have better in a second, but it looks something like that. We say to do the opposite, that means integrate. We put in the bracket what we want to integrate, which in this case is 2x, and then we say dx after that. It just means with respect to x. So that just means obviously do the opposite. That means integrate 2x with respect to x. And we're going to look at how we go about actually doing that. So obviously, as we've said, we're going to increase the power. So at the moment, that power of 2x there, the power of x is a power of 1. So if we increase that, it becomes 2x squared. And then rather than multiplying by that coefficient, we're now going to divide by that. Sorry, rather than multiplying the coefficient by that power, we're going to divide the coefficient by that power. And the power is 2, so we're going to divide it by 2. And you'll see when we do 2x squared divided by 2, we get back to that original x squared that we had up the top there. Okay. Now, the problem with this is, and obviously this isn't going to be the final answer here, the problem with this is that there's quite a lot of different graph equations here that are going to give us 2x when we differentiate it. So if I have a look at another example up here, we could have y equals, and let's just imagine it's x squared plus 5. Now when we differentiate that, obviously we multiply the x squared by the coefficient by 2, and we get 2x. So when we differentiate it, we get 2x, and the 5 then disappears. So that gives us 2x as well. Likewise, we could have something like y equals x squared minus 19. When we differentiate that, multiply the x squared by 2, reduce the power, you get 2x, and the 19 disappears. So again, we get 2x. So the problem here with the integration is that we don't actually know what that constant is at the end, what that number is at the end. And because of that, we have to add something onto our answer when we're integrating, and that is that we have to put plus c at the end, and that is called our constant of integration. Again, that just obviously says that we don't actually know what the constant is, so we always have to put plus c at the end, and that's going to be absolutely essential as we move through this video. Every time we integrate, we're going to have to put that plus c at the end because we just don't know what that constant was unless we have any specific values on our graph. And obviously with the x squared graph, that's quite a nice one, but let's just imagine, just to sort of give you an overview of everything we're going to be looking at, if I imagine that I say, okay, well on this particular graph that we've just integrated, so this x squared plus c, we have an x and a y value. Let's imagine we say, okay, well y equals 5 when x equals 2. Okay, so if y equals 5, when x equals 2, what is that equation going to be? Well, if we sub those values in, x squared is going to be 4, so that would be 4 plus c, and that has to equal 5. So we know in that case there, c would have to equal 1, and the equation of this line in particular would be x squared plus 1, or y equals x squared plus 1. Okay, so something here that looks a lot more complicated, and let's see how we go about this one. So we've got these 3 pieces that we're going to integrate this time. So we're going to start off with this 12x cubed. So again, we're going to increase the power. So we have 12x to the power of 4, and then we're going to divide by that new power, so divide by 4. Then we're going to add to that. We've got 6x, so that's going to go up to 6x squared, and then we're going to divide by that new power, which is 2. And then we're going to take away. And this one's not as nice here because we've got a power of 2/3 there, but we have 15x. We need to figure out what that power is going to be. So we need to add 1 to 2/3. Well, 1 in terms of thirds is 3/3. So if we add 3/3 to 2/3, we get 5/3. There we go, and that's not a 5, so let's rewrite that. We get 5/3. There we go. So 15x to the power of 5/3, and then we need to divide by that new power. So we're dividing by 5/3. Not very nice there. There we go, but divide by 5/3. And then at the end of that, plus c, okay, because we don't know what that constant would have been at the end. But there we go, we just need to simplify this all down, see what we get. These first two look okay. We've got 12 divided by 4, which is 3, so that's quite nice. We get 3x to the power of 4 for the first bit. The next bit, we've got 6 divided by 2, which is 3 again, so 3x squared. And then this bit isn't so nice here. You've got 15x to the power of 5/3 divided by 5/3. And obviously, if you've got your calculator, obviously you can work this out quite nice and easy. But don't forget, it's not too difficult just to do 15 over 1 divided by 5/3. So times it by the flip version, 3/5. And there you go, that equals 45 on the top over 5, which is 9. There we go, so 15 divided by 5/3 is 9. Just a nice little bit of working out there. Obviously not always having to rely on your calculator if you've got some nice quick working out that you can do. So there we go, take away, that becomes 9x to the power of 5/3. There we go, and not forgetting plus c at the end. There we go. And there we go, that's that integrated, okay? Not forgetting that plus c again, that's so important. Obviously something that's obviously new with this, even though we're doing the reverse process of differentiating, that plus c there is so important to make sure that you add on the end. But there we go, that's kind of how we're going to integrate. So increase the power by 1, divide by that new power, and then simplify all your terms and just watch out for any sort of complications when you've got fractions in the powers there, and just being careful with that. Okay, so this question here looks very similar to one we looked at earlier in the video. We've got dy over dx equals x squared plus 5 in brackets squared all over x squared, where x cannot equal 0. Obviously we can't divide by 0, so we can't have x is 0 on the bottom. And it says given that y equals 13 and x equals 1, find y in terms of x, giving each term in its simplest form. So obviously you've got a few little bits to sort out here. You've got a bracket on the top that needs expanding. You're going to have to turn this into a single line, so dividing all of those pieces by x squared and getting those obviously rewritten. But obviously you need to get that into a single line, integrate it, sub these values in, find that value of c. So have a go, see if you can get this question done, see how far you can get. We'll go over the answer in a sec, so pause the video there and have a go. Right, okay, so we need to sort out what's on the top to start with them. So x squared plus 5, obviously squared means we've got to do a double bracket, so we have x squared plus 5 and another x squared plus 5. There we go, so if we expand this all out, we get x to the power of 4, then we get plus 5x squared plus another 5x squared, so that's plus 10x squared. There we go, and then 5 times 5, we get plus 25. So that's what we've got on the top, and that's all being divided by x squared. So obviously we just need to then divide all of these powers by x squared. It's actually not too bad if you've obviously got to this point already. The first piece there, x to the power of 4 divided by x squared. Well, I'll subtract the powers, we get x squared. There we are, the next piece, 10x squared divided by x squared is just 10, so plus 10. And then the last piece there, 25 divided by x squared. Well, subtract the power from x to the power of 0, gives x to the power minus 2. So we get 25x to the minus 2. There we go. And now it's at a point where we can actually integrate it. So if we bring this up and integrate that, let's see what we get. So x squared, well, we'll obviously increase the power, so we get x cubed divided by 3. There we are. Plus 10x, increasing the power of x there. Obviously there's no x before, so we'll introduce the x. And then for the last piece there, if we increase the power, it goes to minus 1. So we get 25x to the minus 1 divided by the minus 1, and then we get plus c at the end. Right, okay, so nearly done. We obviously just need to simplify this down. So we get at the start there, we can obviously write it as a third if you want. You've got 1 in front of the x cubed there, so we've got 1/3 x cubed plus 10x. And then we have 25 divided by minus 1, so it becomes minus 25 x to the minus 1 plus c. And now we can go about subbing these values in. So it says over here y equals 13 at the point where x equals 1. So if we obviously write this as an equation now, let's just get rid of this because we could have put our y equals at the start of that one. Obviously have decided not to as we were integrating it at that point, but now we're looking at it in terms of y equals y in terms of x. We can write that out. So we've got minus 13 is equal to a third times 1 cubed, so a third times 1, which is just a third. You can put the 1 in if you want, let's just write that in anyway, 1 cubed, plus, then we've got 10 lots of 1, which is just 10, take away 25 lots of 1 to the power of minus 1. There we go, 1 to the power of minus 1. You can put in the bracket, and then plus c. Right, so simplifying this down then, we've got minus 13 at the start, obviously, equals, and we have a third times 1, which is a third, plus 10 times 1, which is 10, take away 25, and then 1 to the power of anything is 1, so it's just take away 25 plus c. Obviously, we just need to simplify this little bit down and see what we get. So we've got a third plus 10 take away 25. All right, so if we work that out, then we've got minus 13 equals 10 take away 25 is minus 15. Add the third to that is minus 14 and 2/3. There we go, 14 and 2/3. Obviously, you can check that on the calculator, but there we go, minus 14 and 2/3 plus c. So not the nicest here. How do we get from minus 14 and 2/3 to minus 13? Well, we're going to have to add in those extra 2/3 to get back to minus 14, and then add an extra 1, which is 3/3. So there's 5/3 there that we need to add for c. So our value of c is going to be 5/3. There we go, that would have to be 5/3, there we go. Obviously you could add 14 and 2/3 to negative 13 there, and you'll get your 5/3 or 1 and 2/3. There we go, there's our value of c, and obviously to finish this off we just need to plug it back into the original equation up there for our value of c. So for our final answer here, let's just write this up here, we get y equals 1/3 x cubed plus 10x minus 25x to the minus 1, and then plus 5/3. There we go. And obviously you could write that as a decimal as well if you wanted, but obviously when it comes to thirds I tend to just leave it as a fraction rather than having any recurring decimals in there. But there we go, there's our final answer. Okay, so when having a look at definite integrals, let's have a look at the process for going about that. So this particular question, first of all, we need to integrate 2x minus 3 root x. Now again, I'm going to write that in a slightly different way. I'm going to write the root x as x to the power of a half. So I'm going to write this as 2x minus 3x to the power of a half. Now to start with, all we're going to do is integrate here. So if we integrate that, we will have, and let's just have a look at what we get. We get 2x squared over 2, and then increasing the power there for the power of a half, we get 3x to the power of 3 over 2, and we're going to divide that by 3 over 2. Now at this point here, you are okay to simplify this, so we'll simplify this a little bit. Now you don't have to, because we're going to type this into a calculator anyway when we go about this, but we can simplify that. So the first piece there, if we divide that by 2, we get x squared, and for the second piece, when we divide that by 3 over 2, we get 2x to the power of 3 over 2. So now we have integrated it, what we are going to do is do a definite integral. So for this, what we are going to do is we are going to substitute the number 9, the first number on the top of the integral. We're going to substitute the number 1 in, and we're going to subtract them away from each other. So when we write this, we put our integrated piece into a squared bracket, and you will also notice that I haven't put the plus c on the end. Now you're going to see here why I haven't put the plus c, so we'll come back to that in just a second. So the first number we're going to use is the 9, the second number we're going to use is 1. And if I go about doing that, I'll get something that looks like this. So I will put 9 in to start with. So that will be 9 squared. Take away 2 times 9 to the power of 3 over 2. And there we go. And then we are going to take away whatever it is when we substitute 1 in. So if I substitute 1 in, we'll get 1 squared. Take away 2 times 1 to the power of 3 over 2. And there we go. That is going to work out our answer. Now you'll notice that we didn't need to put the plus c in, because we are going to take these away from each other when doing a definite integral. You'll notice that if I had have put a plus c in the first bracket, I would be taking away a plus c in the second bracket, and therefore they would cancel out anyway. So putting that in is kind of pointless. So if we work this out and type that into a calculator, you will see that I get the answer 28. So our final answer for this is 28. Now on a later question you are going to see what we use this for, but this was just a practice of going over how to go about doing this. So as you can see, we integrate it, we put it into the squared bracket showing the 9 and the 1, and then we substitute 9 in, substitute 1 in, and take them away from each other. And again, if we had different numbers there, we would sub those numbers in, but again we would just take them away from each other, and we're looking to see what our answer is. Okay, so in this question we are going to see what we use definite integrals for, and this question here says find the area of the finite region between the curve with equation y equals x brackets x minus 4 squared and the x-axis. So this is going to show you what we use definite integration for. Now if we were to draw this curve and think what it looks like, it would be a cubic graph, and it's a positive cubic graph as well. Now you can see here we get our solutions of x equals 0, and we've also got an x equals 4 solution there, and that's a repeated solution, so it's going to bounce on the axes. So our graph would come up through 0, bounce on 4, and then go back up. So if we label that on, we've got 0 here and 4 just here, and hopefully now you can see that finite region between the curve and the x-axis. So if I highlight that, we are looking at this region here. So when we are using definite integrals, we use it to find the region bounded between two of these points. So in order to do this, we're going to have a look at the equation of the curve. We are going to do our definite integrals between 0 and 4, and that will tell us the area that is bounded between those points. Again, it does tell us the area as it is bounded towards the x-axis, so we would have to do something different if it was bounded between the curve and another line, but again we will look at that as well. So in order to integrate this, we'd probably want to expand that equation. So if we expand that equation, if we do the double bracket first, we would get y is equal to x lots of, if we expand that double bracket, we get x squared minus 8x plus 16. Now we'll multiply it by the x as well, so we're going to get y is equal to x cubed minus 8x squared plus 16x. Now we can go about actually integrating this, and if we integrate that, and again we're going to do it between these 2 points, so we'll write that we're going to do it between 4 and 0. So when we integrate that, we get x, let's have a look. In fact, let's just write down on what we're going to integrate. We're going to integrate x cubed minus 8x squared plus 16x. And when we integrate it, then we can just go ahead and write it in our squared bracket. So increasing the power then, we get x to the power of 4 over 4, take away 8x to the power of 3, all over 3. Let's just make sure I write that 3 a little bit better. And then that is going to be plus 16x over 2. And of course you could write that as 8x squared. Sorry, 16x squared over 2. You could write that as 8x squared. Now that's what we're going to be using for our limits here, so we'll put that into our squared bracket, and we're going to use 4 first and 0 second. It's quite a nice one when it does have 0, it does make this second step quite nice. So when we put the numbers in, let's have a look at what we get. Putting 4 in to start with, and again let's just write it in because we're just going to type this in on our calculator. So we have 4 to the power of 4 divided by 4. Take away 8 times 4 cubed, all over 3, and then plus 16 times 4 squared, all over 2. And we're going to take away the second one, which is substituting in 0. Now if you have a look, if you substitute 0 into the first piece, you get 0 over 4, so that's 0. The second piece, you get 0 over 3, and the third piece, you get 0 over 2. So all of that just comes out as 0. Again, you can substitute 0 in if you want, but just looking at it, you can see they all come out as 0. So if you type all of that into your calculator, we get the answer, and it comes out as 64 over 3. And there we go, that is our area. So the area that we are looking at there is 64 over 3. You could convert that into a mixed number if you want, so you could write that as 21 and a third, but either of those answers are fine, and we could leave our answer in either form. So there we go, that is our final answer. That's what we use this definite integration for. We find the 2 points that are bounded by the curve and the axes, and using this we can work out the area underneath. Okay, so when looking at specific areas, sometimes we'll be looking at areas that are also under the x-axis, and we just have to take something into account when we do this. So if we think about what this curve would look like for this particular question, we will have something going under the x-axis. So you will see when I expand this bracket and or if I draw a sketch of it, what it would look like. So if we draw a little sketch to the side and think about our solutions, we've got x equals 0, and again we're just looking at this curve here. We have got x is equal to 1, and we have x is equal to negative 3. So again, the question just says to find the finite region between the curve and the x-axis, but you will see when I draw this, we have a point at negative 3, we have a point at 1, and we have a point at 0. And when I draw this curve in, again just drawing a sketch of it, so it's not to scale, but it is going to go up through negative 3, down through 0, and then up through 1. And you can see here that we have a finite region above the x-axis here, and we have another one below the x-axis here. And when we are working this out, something's going to change in our answer. We'll have a look at that when we get to it, but for now we just need to follow very similar steps. We're going to integrate our equation, and then we are going to use our definite integration between these 2 points, but we're going to do them separately. So we're first going to have a look at between negative 3 and 0, and then we're going to have a look between 0 and 1. So first of all, let's expand those first 2 brackets. So that would give us y is equal to x squared minus x. And we're going to multiply that by the third bracket there, or the third piece. Obviously the first piece wasn't a bracket, but we're going to multiply that by x plus 3. If we expand that out, we're going to get y is equal to x squared times x is x cubed. Then we get plus 3x squared minus 2x squared, so plus 2x squared. And then negative x times 3 is minus 3x. So that is our equation expanded. Now we're going to integrate it. So if we integrate that, we get x to the power of 4 over 4. Then we get plus 2x cubed over 3. And then for the final piece there, we get minus 3x squared over 2. Again, we're not going to put our plus c in there because we are going to be using our limits, and therefore that plus c is going to disappear anyway. So we'll put this in brackets, we'll put our dx at the end, as we know that is what we are using. So when we put our limits in, we're going to do this in 2 parts. To start with, we will have a look at the first part here, and then we will have a look at the second part. So if we start by having a look at the first part, we are going to put our limits in now, so that is between 0 and negative 3. And if we substitute our numbers, and we're doing this with respect to the y equation, so we'll put y dx here, and then we'll substitute our numbers in. So when we go about doing this, just so that we don't have to rewrite that full equation, then we can put 0 in to start with, which if you have a look just comes out as 0. And then we're going to take away, and we need to now substitute negative 3 in. So we have negative 3 to the power of 4 all over 4 plus, in our second fraction, 2 times negative 3 cubed all over 3, and then take away 3 times negative 3 squared all over 2. And there we go. If we work that out and type that into our calculator, for that we get the answer, and let's just put this up here. So for our first one, we get the answer 45/4. So that area comes out as 45/4, which you can leave like that for the moment, and that is our first area. Moving on to the second one, and this time we are going to integrate between the points 1 and 0. Let's just change that naught there, so that this time is between 1 and 0. Again, so we don't have to write the full equation, we'll put y dx, and this time, when we substitute 1 in, let's have a think, we get 1 to the power of 4/4, so that's just a quarter, plus 2 times 1 cubed is just 2, so it's plus 2/3. Take away 3 times 1 squared, so 3/2. There we go. And we are going to subtract, when we sub 0 into all of it, we already know that comes out as 0, so that comes out as 0, and that comes out as negative 7/12. Now, this is the important part, and this is where something changes when it's under the axes. An area cannot be negative, but when it comes out in this form in integration, it knows that it's under the axes, and it gives us the area as a negative 7/12. So all we have to do is we change that area to a positive number, so we write that it's positive 7/12. And that is literally it for this extra element when it is under the axes or under the x-axis. So when you get a negative area, you know it's under the x-axis, and as an area, we just write it as the positive version. So to finish this question off, now we know that the area is positive, we just add them together. So 45/4 plus the positive 7/12, and that comes out as, and you can do this on the calculator, it comes out as 71/6. So there we go, that is our final answer, 71/6. Again, you could turn it into a mixed number if you want, but it's not required and it's not necessary, so we're going to leave that as 71/6. Okay, so looking at this question, it says the curve C has equation y equals x squared plus 2. It says the line y equals 6 intersects curve C at the points A and B. Find the area of the finite region bounded by the curve C and the line AB. So if we draw a sketch of this to see what it looks like, the x squared plus 2 is just an x squared graph that's been translated up by 2. So it would look something like that. Now if it's been translated up by 2, it does cross through the x-axis at point 2 just here, and that will also help us to draw the line y equals 6, as we know it has to be above that. So if we draw that line in as well, it goes across here, through the point 6, and it crosses over here and here. So we can call that point A, and we can call this one point B. So we are looking at the area that is bounded by the curve and the line AB. So that is going to be this area just here. So again, this is above the x-axis, but it is bounded by that line y equals 6. So this is an area between a curve and a line. Now when we go about doing this, we just need to think logically about how we would work that out. If we can find the coordinates of A and B, we can go down and we can imagine where the x coordinate would be just here. If we do the same with B, we know the x coordinate is going to be just there. And that is going to form a rectangle. Now if we were to work out the area of that rectangle and then subtract the area underneath the curve just here and over here, then that would just leave us with the shaded region that is bounded by the curve and the line. So to start with, we can take many multiple steps here, but I'm going to start with solving to find the coordinates where they cross over, and we can do that by setting these equations equal to each other. So if we take the equation of the curve, x squared plus 2, set it equal to the equation of the line, which is 6, and now we can solve that. So if we solve this, we get x squared is equal to 4, and therefore if we square root both sides, x has to be equal to plus or minus 2. So if x is equal to plus or minus 2, we can see that the x coordinate will be 2 over here. It will be negative 2 just over there. So now we can work out one of two things. We can either work out the area under the curve, or we can work out the area of the rectangle. Probably easier for us to just get the area of the rectangle so we don't forget. So for the rectangle, there we go. That has a base length across here of -2 to 2. So that is a base length of 4. And it has a height going up here, going from the x-axis up to the y=6 line, so it has a height of 6. So the area of our rectangle is going to be 4 along the bottom multiplied by 6, which is equal to 24. So I'm going to underline that so we don't forget about that one. Now we want to find the area under the curve. This is quite nice as it's just between -2 and 2, so we're not going to have to do this twice like on some of the other questions. So if we write this out, we are going to integrate between 2 and -2, and the piece we're going to integrate is x squared plus 2. So we just write x squared plus 2 dx. Now we can actually go about integrating that. So if we go about writing this out, we could put it into our squared brackets, and we would say, and let's just integrate that now. So that would become x cubed over 3 plus, and then increasing the power of 2 just makes it 2x. And again, we'll just write the limits there, which is 2 and -2. So now we just need to go about actually substituting those numbers in. So if we substitute 2 in, let's see what we get. So for the first one here, if we substitute 2, we get 2 cubed divided by 3 plus 2 times 2. For the next one, which we're going to take away, we've got something very similar looking, and that is -2 cubed divided by 3. And then that is going to be plus 2 times -2. There we go. And that is what we need to work out. So if we type that into our calculator, let's see what we get. We get the answer 40 divided by 3, or 40 over 3. Now that again could be written as a mixed number, but of course you don't need to write it. We can just leave it as 40 over 3. So we have the pieces that we need. We know that the area of the rectangle was 24, and the area under the curve there, bounded by the x-axis, is 40 over 3. So we already discussed at the start that to get this area here that is between them, we just need to subtract them away from each other. So we'll take the area of the curve, the area of the rectangle, which is 24, and subtract the area under the curve, which was 40 over 3. And if we just typing that into our calculator, we get the answer that comes out as 32 over 3. Or of course, you could write that as a mixed number. You could write it as 10 2/3, but 32 over 3 is fine. So 32 over 3 would be the final answer for the area that's bounded by the line y=6 and the curve. Okay, well done for making it to the end of this chapter. Don't forget to check in the description for the rest of the other chapters that we'll be looking at throughout the AS Pure Mathematics curriculum. And until next time, I will see you on the next chapter.